Water pollution, causes, effects, and control measures. Introduction. Water is essential for life. Without water, there would be no life. 71% of the Earth's surface is covered by water. Only a teeny fraction of this water is available to us as fresh water. About 97% of the total water available on Earth is found in oceans and is too salty for drinking or irrigation. The remaining 3% is fresh water. Of this, 2.997% is locked in ice caps or glaciers. Thus, only 0.003% of the Earth's total volume of water is easily available to us as soil moisture, groundwater, water vapor, and water in lakes, streams, rivers, and wetlands. Water that is found in streams, rivers, lakes, wetlands, and artificial reservoirs is called surface water. Water that percolates into the ground and fills the pores in soils and rock is called groundwater. Porous water saturated layers of sand, gravel, or bedrock through which groundwater flows are called aquifers. Most aquifers are replenished naturally by rainfall that percolates downward through the soil and rock. This process is called natural recharge. If the withdrawal rate of an aquifer exceeds its natural recharge rate, the water table is lowered. Any pollutant that is discharged onto the land above is also pulled into the aquifer and pollutes the groundwater, resulting in polluted water in the nearby wells. When the quantity or composition of water changes directly or indirectly as a result of man's activities such that it becomes unfit for any purpose, it is said to be polluted. Any physical, biological, or chemical change in water quality that adversely affects living organisms or makes water unsuitable for certain use is referred as water pollution. We usually take water as granted for its purity, but we must ensure the quality of water. Pollution of water originates from human activities. Through different paths, pollution reaches surface or groundwater. Easily identified source or place of pollution is called as point source. Example, municipal and industrial discharge pipes where pollutants enter the water source. Non-point sources of pollution are those where a source of pollution cannot be easily identified. Example, agricultural runoff from farm animals and croplands, acid rain, stormwater drainage from streets, parking lots and lawns, etc. Causes of water pollution. There are several classes of common water pollutants. These are disease-causing agents, pathogens which include bacteria, virus, protozoa and parasitic worms that enter water from domestic sewage, and untreated human and animal waste causing different types of waterborne disease. Human excreta contain bacteria such as Escherichia coli and Streptococcus faecalis which causes gastrointestinal disease. Another category of water pollutants is oxygen depleting wastes. The amount of oxygen that water can hold in the solution is limited. In cold water, dissolved oxygen can reach a concentration up to 10 ppm parts per million, whereas oxygen in air is about 2 lakh ppm. That is why even a moderate amount of organic matter when decomposes in water can deplete the water of its dissolved oxygen. The concentration of dissolved oxygen in water is very important for aquatic life. If the concentration of dissolved oxygen of water is below 6 ppm, the growth of fish gets inhibited. Oxygen reaches water either through atmosphere or from the process of photosynthesis carried out by many aquatic green plants during daylight. If too much of organic matter is added to water, all the available oxygen is used up. The organic wastes that can be decomposed by aerobic oxygen requiring bacteria. Large populations of bacteria use up the oxygen present in water to degrade these wastes. In the process, this degrades water quality. The amount of oxygen required to break down a certain amount of organic matter is called the biological oxygen demand, BOD. The amount of BOD in the water is an indicator of the level of pollution. If too much organic matter is added to the water, all the available oxygen is used up. This causes fish and other forms of oxygen dependent aquatic life to die. Thus, anaerobic bacteria, those that do not require oxygen, begin to break down the wastes. Their anaerobic respiration produces chemicals that have a foul odor and an unpleasant taste that is harmful to human health. A third class of pollutants are inorganic plant nutrients. These are water-soluble nitrates and phosphates that causes excessive growth of algae and other aquatic plants. The excessive growth of algae and aquatic plants due to added nutrients is called eutrophication. They may interfere with the use of the water by clogging water intake pipes, changing the taste and odor of water, and cause a buildup of organic matter. As the organic matter decays, oxygen level decreases and fish and other aquatic species die. The quantity of fertilizer applied in a field is often many times more than is actually required by the plants. The chemicals in fertilizers and pesticides pollute soil and water, while excess fertilizers cause eutrophication, pesticide causes bioaccumulation and biomagnification. Pesticides which enter water bodies are introduced into the aquatic food chain. They are then absorbed by the phytoplanktons and aquatic plants. These plants are eaten by the herbivorous species, which are in turn eaten by the carnivorous species, which are in turn eaten by the water birds. At each link in the food chain, these chemicals which do not pass out of the body are accumulated and increasingly concentrated, resulting in biomagnification of these harmful substances. One of the effects of accumulation of high levels of pesticides such as DDT is that birds lay eggs with shells that are much thinner than normal. This results in the premature breaking of these eggs, killing the chicks inside. Birds of prey such as hawks, eagles, and other fish-eating birds are affected by such pollution. Although DDT has been banned in India for agricultural uses and is to be used only for malaria eradication, it is still used in the fields as it is cheap. A fourth class of water pollutants is water-soluble inorganic chemicals, which are acids, salts, and compounds of toxic metals such as mercury and lead. High level of these chemicals can make the water unfit to drink, harm fish and other aquatic life, reduce crop yields, and accelerate corrosion of equipment that use this water. Another cause of water pollution is a variety of organic chemicals which include oil, gasoline, plastics, pesticides, cleaning solvents, detergents, and many other chemicals. These are harmful to aquatic life and human health. They get into the water directly from industrial activity, either from improper handling of the chemicals in industries and more often from improper and illegal disposal of chemical waste. Sediment of suspended matter is another class of water pollutants. These are insoluble particles of soil and other solids that become suspended in water. Water-soluble radioactive isotopes are yet another source of water pollution. These can be concentrated in various tissues and organs as they pass through food chains and food webs. Ionizing radiation emitted by such isotopes can cause birth defects, cancer, and genetic damage. Hot water let out by power plants and industries that use large volume of water to cool the plant result in rise in temperature of the local water bodies. This heated water, which is at least 15 degrees Celsius higher than the normal, is discharged back into the water body. The warm water not only decreases the solubility of oxygen but changes the breeding cycles of various aquatic organisms. Oil is washed into surface water in runoff from roads and parking lots, which allow pollutes groundwater. Leakage from underground tanks is another source of pollution. Accidental oil spills from large transport tankers at sea level have been causing significant environmental damage. Groundwater pollution. Groundwater is polluted due to urban runoff of untreated or poorly treated wastewater and garbage. Industrial waste storage located above or near aquifers. Agriculture practice such as the application of large amount of fertilizers and pesticides, animal feeding operations, etc. in the rural sector. Leakage from underground storage tanks containing gasoline and other hazardous substances. Leakage from landfills, poorly designed and inadequately maintained septic tanks, mining wastes, arsenic poisoning and other heavy metals contamination. International standards for drinking water. Fluoride. For drinking purpose, water should be tested for fluoride ion concentration. Its deficiency in drinking water is harmful to men and causes diseases such as tooth decay, etc. Soluble fluoride is often added to drinking water to bring its concentration up to 1 ppm or 1 milligram per decimeter cube. However, fluoride ion concentration above 2 ppm causes brown mottling of teeth. At the same time, excess fluoride over 10 ppm causes harmful effect to bones and teeth. Lead. Drinking water gets contaminated with lead when lead pipes are used for transportation of water. The prescribed upper limit concentration of lead in drinking water is about 50 ppb. Lead can damage kidney, liver, reproductive system, etc. Sulfate. Excessive sulfate greater than 500 ppm in drinking water causes laxative effect, otherwise at moderate level it is harmless. Nitrate. The maximum limit of nitrate in drinking water is 50 ppm. Excess nitrate in drinking water can cause diseases such as methemoglobinemia, blue baby syndrome. Other metals. The maximum concentration of some commonly metals recommended in drinking water are metal and their maximum concentration in ppm. Iron 0.2, manganese 0.05, aluminium 0.2, copper 3, zinc 5, cadmium 0.005. Control measures for preventing water pollution. Setting up effluent treatment plants to treat waste. Recycling of water must be encouraged. Industrial wastes must be treated before discharge. Educate public for preventing water pollution and the consequences of water pollution. Strict enforcement of Water Pollution Control Act. Continuous monitoring of water pollution at different places. Developing economical method of water treatment.